Hey guys, it is a beautiful day to jump into key features of rational functions. We're going to find excluded values, and those excluded values that we're going to focus in on are vertical asymptotes and holes. And there's a couple ways we can verify vertical asymptotes and holes. We're going to do it two ways. We are going to factor and simplify, and we're going to check out good old-fashioned Desmos, okay? Because those are going to be our helpful tool in order to do this. So the first thing we are going to do right now is we would type in our equation, and I actually already have that in here. So we will look at that in just a second. The second thing we are going to do, so go to Desmos. The second thing we are going to do is factor in order for us to check some things out. So I've got x squared minus 1. I'm going to go to Desmos and factor this. We can use the area model, but I'm going to go to Desmos because these have a leading coefficient of 1. So they're nice and easy to get done. So when I turn on x squared minus 1, you're going to notice that we have a negative 1 as a root, positive 1 as a root, and we can go ahead and write our factors as x plus 1, x minus 1. And so let's go back to our class kick and let's clear that out. And I'm going to write that in the numerator. So x plus 1 and x minus 1. Now, I'm going to do the same thing. I'm going to find my, I'm going to factor x squared minus 2x minus 3 in Desmos as well. Turn this one off. And let's go to the other one. You'll notice that we have x minus 1 and negative 1 and positive 3, which means we're going to have the factors of x plus 1 and x minus 3. So I'm going to do that. I'm going to write x plus 1 and x minus 3. Now remember, we take those x-intercepts, we put them in as opposites, and then we will make those factors nice and easy. Okay, so number 3, once we've got it factored, we are going to find the excluded values, okay? Remember, excluded values are found in the denominator, okay? So right there, found in denominator. And the reason why they're excluded values is because we cannot divide by 0. So cannot divide by 0. We're going to get an undefined answer if that's the case. So all we have to do is come up here and say, well, what does x have to be in order for that value right here to be 0? Well, if I put negative 1 in, I get negative 1 plus 1, which is 0. And then if I put a x equals to 3 in this statement, that would give us a 0. So these guys right here are our excluded. Okay, in our domain, negative 1 and 3 cannot exist. Let's check it on Desmos. Okay, so we go to Desmos. I'm going to go to that graph, which I've got typed in here to save us a little bit of time. And I'm going to drag it along, and I'm going to look for negative 1 and check it out. Negative 1 on our graph is undefined. You'll also notice, check out on Desmos, it does a great job of showing us a circle that is not filled in. That tells us it is not included, and there's not a distinct break. It is just a hole, and we can tell it's a hole because it's a circle with an empty circle in the graph and not a distinct break. So I'm going to come back to my class kick right here, and I'm going to say, hey guys, we just figured out x equals negative 1, that's a hole, okay? And then I'm going to go over to x equals to 3. Let's check out that graph right there, x equals to 3. Well, if I take a moment and just look at the pier, there is a distinct graph break. So there is a distinct break. Okay, and that distinct break is our vertical asymptote, and I just have to figure that out. So let's go ahead here, let's go and say, okay, well, where is that distinct break? Well, check it out right here. If I go up and I go down at x equals to 3, that's your distinct break. That is your vertical asymptote. So I'm going to go back here. Let's go ahead and identify that. I'm going to say x equals to 3 is our vertical asymptote. Woo! Now, how can we find that on a from our factors, okay? So that's what we need to know. How do we find it from the equation? Determine from equation or the function, okay? Well, let's go back up here. The first thing I want to write down is holes cancel in denominator. Completely, not just one, but they completely cancel in the denominator. Notice that we said the whole was -1. Well, that's because x plus 1 cancels with x plus 1. There are no more x plus 1s in the denominator. That gives us a whole, okay? Vertical asymptotes stay in the denominator. Even if you cancel a bunch of them out, if there's still one in the denominator, it's going to create a vertical asymptote. Okay, now check it out. X minus 1, x minus 3 cannot cancel because there's not an x minus 3 up at the top. We have fully simplified this. X plus 1 cancels out, and we are left with this statement, x minus 1 over x minus 3. So now how do we even check if we've done the simplification correctly? I'm going to go over to Desmos. I am going to type that beast in. So let's go over here. I'm going to write x minus 1. I'm going to divide it by x minus 3. Bada boom, bada bing. Check it out. If we've done it correct, they are equivalent. They are equivalent, which means their graphs are going to overlap. So we've simplified the whole. We found the whole. We determined the vertical asymptote as a break in the graph. And we went ahead of the schedule and we went ahead and simplified that rational function. I hope y'all enjoyed it. Y'all have a great day. It's beautiful.